Hi, myself Satish Koja. Today I want to discuss about a few shortcuts regarding to the K-Cet 2021 Physics chapter on electric charges fields. Okay, so if you are the first viewer, please subscribe my channel. This is my channel. Okay, so see what if you see that last 6 years, 7 years question papers means 2020 to 2015. If you go electric charges and fields. From this chapter, they are focused in a particular areas. Now, I will explain the particular areas. If you watch this video, damn sure you can get maximum marks in this chapter. The weightage of this chapter is minimum 4, maximum 6. Please, now go to the video. See, electric charges and fields. Electric charges and fields. Okay guys, so basic first starting, if you go for the before 2015, they used to ask one question from the basic property of charges. What is the basic property of charges? We have basic property of charges. Like charges repulse each other, unlike charges attract each other, and charge is quantized. Based on this property only they ask, charge can be written as Q is equals to plus or minus Ne. Here N is an integer, E is a charge of electron. E is equals to 1.6 into 10 power minus 19 Coulomb. Now, if you watch the previous year question papers, they used to ask the question from this area. Calculate the number of charges in 1 Coulomb charge. So, means 1 Coulomb charge means Q they given 1 Coulomb. They ask what is N value. So, N equals to Q by E. So, Q value they given 1. This E value 1.6 into 10 power of minus 19. This we can write as 1 by 16 into 10 power 20. This is 6.25 into 10 power 18. These many number of we have. This is the old question paper. If you see the old question paper, they used to ask the question from this area. Calculate the number of electrons or number of protons in 1 Coulomb charge they will ask. This is the way. This is for 1 Coulomb charge. These many we have. Okay, this is the fundamental question. They are focused on the basic property of charges. Now coming to the second part is nothing but Coulomb's inverse square law. We know that when you go for PUC board examination, this is an important question that is called as Coulomb's inverse square law. Coulomb's inverse square law means according to Coulomb, the electrostatic force means either it is the attraction force or the repulsive force is always directly proportional to the product of the magnitude of the charges. I repeat once again, magnitude of charges and inversely proportional to the square of the distance. See, this is the way we are writing the formula, Coulomb's inverse square law. See, F equals to 1 by 4 pi epsilon naught, product of the charges, magnitude we should take by distance d square. Okay. If you see the previous year questions, means 2015 to 2020, they used to ask the questions from this area only. Now see, so Coulomb's inverse square law if you take, so they write, they given one time, two charges we have, this is the charge Q1, this is the charge Q2. These two are separated by distance d, then the force is F. Okay, now these two are contact with each other, means contact with each other a few seconds, again they are separating. Means this is Q1 dash and this is Q2 dash. Now what is the separation between them is D only. Then what is the new force they ask? If you take this is F1, this is F2. So what is F2 value they ask? Guys, you see here distance is same. So we have to focus only charges. So when these two are contact with each other, we know that due to the conduction process, the new charges Q1 dash and Q2 dash can be written as Q1 plus Q2 by 2. This is the new charge on the two bodies. Now if they ask F2, F1 by F2, we can write is equals to Q1 by Q2 by Q1 plus Q2 whole square into 4. This is the shortcut formula. 4 types of Q1, Q2 by Q1 plus Q2 whole square. F1 by F2 is equals to 4 into Q1 Q2 by Q1 plus Q2 whole square. Okay, this is the way we can, this is the shortcut we can use. And similarly, sometimes they ask if the same charges, the distance is increases or distance is decreases, means see, F is inversely proportional to each other. According to Coulomb, F is inversely proportional to each other. Means when we are discussing about the distance, we can write F1 by F2 is equals to D2 by D1 whole square. Okay. Now see guys, if D1 is equals to D, D2 is equals to N times of D, means they are increasing the distance N times. The new force, if they ask F1 by F2, we can write D2 by D1 means ND by D whole square, means this get cancelled. So new force F2 is equals to original force by N square. This is the shortcut we can use. This is the shortcut. Whenever they given the distance increased by D times, they are increasing the distance N times, then the force is decreased by N square times. The same problem if they give in another way, if they are decreasing the distance N times, means if D1 is equals to D, D2 is equals to decreased by N times, then what is the new force? What is the new force means, again we are using the same formula, F2 by F1 is equals to D1 by D2 whole square. Okay, so D1 by D2, so D1 is D, D2 is D by N, so N will go to the numerator, so this get cancelled. So F2 equals to N square times of F1. Guys, yes, repeat it once again. See, I repeat it once again. If the distance increases, force will decreases. If the distance decreases, force increases. So new force F2 is equals to N square times of original force or initial force. This is shortcut. Decreases means force increases. Distance increases, force decreases. Okay? Kammi jasti. Okay? See, this are the shortcuts. Now see, here we have the epsilon naught. Epsilon naught is called as permeability or permittivity. Sorry, permittivity. The epsilon naught value is permittivity. Permittivity of free space. This value is 8.8542 into 10 power minus 12. This is constant. Here we have a dielectric constant or relative permeability. This is equals to epsilon r, or we can call as dielectric constant K is equals to epsilon by epsilon naught. Okay, this dielectric constant value is constant for air. If you take, it is equals to 1. For water, if they give conductors, is equals to infinite. Okay, this air, water, conductor. Understood? This is the first part. They used to ask the questions based on the Coulombs law. Okay, now see, second part. If you do, we have two charges Q1 and Q2. Okay, if these two are separated by distance D, listen to me. Now this relative permeability concept we are using here, force in a medium means 1 by 4 pi epsilon into Q1 Q2 by distance D square. This is F medium. Now we want, see, K is epsilon is equals to, we can write K into epsilon naught. Okay, means F force in given medium is equals to 1 by this epsilon, we can write 4 K into 4 pi epsilon naught Q1 Q2 by D square. Means force in medium, any medium, is equals to force in vacuum or force in air by the dielectric constant value. Sometimes they will give dielectric constant value like this. Dielectric constant, we can write K is equals to force in air by force in given medium. Force in air by force in given medium. So this is the way we can write dielectric constant. Okay, so this is the problems related to the Coulomb's inverse square law. Now coming to the second part, electric field. समझे? आता See, this is K equals to F air by F medium. Okay, this medium, if they ask force in air and dielectric constant they given, then we can easily calculate this. See, the force in medium is equals to, it is decreased by K times. Okay, now electric field. Electric field is nothing but the force experienced by unit positive charge. So electric field we can write E bar is equals to force experienced by unit positive charge. So we can write units Newton by Coulomb, or we can write volt by meter. Okay, so see here, electric field due to the point charge, we can write E is equals to 1 by 4 pi epsilon naught charge q by distance d square. Okay, now see, we can write easily electric field is always directly proportional to the charge, and electric field is inversely proportional to the square of the distance. Means if we are increasing the magnitude of the charge, field increases. Means charge jasti, field jasti. If ಕಮ್ಮಿ ಇದು ಕಮ್ಮಿ ಅರ್ಥ ಆಯ್ತಾ, ಜಾಸ್ತಿ ಆಯ್ತು ಫೀಲ್ಡ್ ಜಾಸ್ತಿ ಚಾರ್ಜ್ ಜಾಸ್ತಿ, ಇದು ಕಮ್ಮಿ ಆಯ್ತು ಇದು ಕೂಡ ಕಮ್ಮಿ ಆಯ್ತು. ಓಕೆ, so this is the relation between electric field and charge. Now see, this is the formula for electric field. Now we have two types of electric fields. One is uniform electric field, second one is non-uniform electric field. Okay, now see, what is the motion of a charge? What is the motion of the charge when it is placed in a uniform electric field? See, motion of a charge in a uniform electric field. See, this from this area they used to ask the question, motion of a charged particle in a uniform electric field. Uniform electric field. Okay, now see, we have an electric field like this. This is an electric field of intensity E bar, uniform electric field. Okay, now if we place a positive charge Q, the force F is equals to E. This is the first point. The force acting on the charged particle is F is equals to EQ. Now see, positive charge means if it is a positive charge, electric field and force in same direction. In same direction. Negative charge means electric field and force opposite direction. Means if you take this is a negative charge, the force is acting this side. F is equals to EQ. Okay, so force and charge are in the same direction if you take positive charge. Now see, if it is initially at rest, they ask what is the acceleration, what is the distance traveled by the body, what is the velocity. Okay, now see, this charge having mass m, so electrostatic force, if you take EQ from the Newton's second law, F is equals to mh. If they ask acceleration, this is the formula. This is the shortcut for acceleration. Acceleration. Sometimes they will not give electric field. Sometimes second chapter electric field and potential and capacity is there. There we have the relation E is equals to V by D. So this E we can write in terms of the D. So this we can write VQ by MD. This is also correct. Potential into charge by M into D. Understood? This we can write. Okay, and see, now they will ask how much distance is travelled. So use the formula S is equals to UT plus half AT square. Initial at rest, so 0. Distance travelled is equals to half EQ by M into T square. This is the formula. EQ by M into T square. S is equals to EQ by M into T square. This is the formula. Okay. So acceleration is, if they ask work done is equals to force into displacement. So this is the problem they ask. Work done is equals to force into displacement. I gave the formula here. F is equals to EQ. So work done is equals to EQ into D. This is most repeated question in CET. Work done is equals to EQ into D. Work done formula, force into displacement. Force is equals to EQ. Distance is D. This is repeated question. Repeated. Box. Okay? Box. Work done is equals to EQ into D. One time in CET, instead of the D, they given Y. So this is the option. EQY. Okay? So I am writing here EQ into D. Okay? Electric field, charge, distance. So this is about uniform electric field. Shortcut, see acceleration formula EQ by M. If they don't give electric field, potential and distance they given. So they may give here the two parallel plates, they will give parallel plates, capacitance, distance they will give, potential they given. So E you can replace V by D. So distance they ask, this is the formula. Work done they ask EQ into D. Okay? This is about uniform electric field. Next important concept is dipole. Dipole. Di means two. Two poles we have. Dipoles means, di means two. Two poles. Two poles means two equal and unlike charges. Two equal and unlike charges. Separated by a small distance. Let us consider this is A, this is A, this is Q, this is Q, this is negative, this is positive. Two equal and unlike charges separated by a small distance is called as dipole. So dipole moment. P bar is equals to product of either of the charge Q into distance between these two, 2A, means units Coulomb meter. This we call as dipole. Another unit is dipole. Coulomb meter dipole. Yes, this is the dipole moment. Direction of the dipole momentum. Direction of P bar is negative charge to positive charge. This is important. Here they will ask the questions. One is axial line, second one is bisectional line, and third one, if this dipole is placed in uniform electric field, they ask what is the time period also they ask. Okay? See, okay? Right. Dipole we have 2 points. One is axial point. So dipole, axial point formula. Axial point means EA is equals to 1 by 4 pi epsilon naught. EA is equals to 1 by 4 pi epsilon naught. 2p r by r square minus a square whole square. This is the formula. 2p r by r square minus a square whole square. Guys, here you should know one direction. EA bar means electric field and dipole momentum P bar are in same direction. Means theta is equals to 0. Okay. For the short dipole, if you take, this is the formula for axial line. EA bar is equals to 1 by 4 pi epsilon naught 2p by r cube. This is formula for small dipole. Okay, for equatorial plane or bisectional line. So EB equals to I'm writing here EB equals to 1 by 4 pi epsilon naught P by R square plus A square whole power 3 by 2. Okay, this is, and see here EB bar and P bar dipole momentum are in opposite direction, so theta is equals to 180 degrees. For the short dipole, if you take EB is equals to, for the short dipole, for short dipoles EB is equals to 1 by 4 pi epsilon naught P by R cube. Guys, you see, if you take short dipoles, EA is equals to 1 by 4 pi epsilon 2 P by R cube, EB is equals to 1 by 4 pi epsilon P by R cube. They ask what is the relation between EA and EB. Suppose if you take magnitude of EA, E is equals to 2 times of magnitude of EB. This is the shortcut. This is several times they ask in NEET examination and AAPMT. Okay, EA is equals to 2 times of EB. Okay, this is about dipole. Okay, so instead of learning these many points, I give one shortcut. See, for the dipoles, for a short dipoles I give one shortcut. This is shortcut for short dipoles. This is for short dipoles. This is E is equals to, at any point 1 by 4 pi epsilon naught into P by root of P by R cube, you write 3 cos square theta plus 1. This is the shortcut. Okay, 1 by 4 pi epsilon naught P by R cube 3 cos square theta plus 1. Okay, this is about dipoles. Next one is Gauss law. Gauss law, we know that flux is equals to Q by epsilon naught. Flux is equals to Q by epsilon naught. See, for this I will tell one shortcut. Gauss law is applicable for only closed surfaces. Means if you take one cube like this, a charge is placed at the center. If they ask total flux is equals to Q by epsilon naught. Guys, I will tell you one point. So cube have 8 sides. Okay, cube have 8 corners and 6 sides. We have 6 sides. So for 6 sides we have the formula Q by epsilon naught. If they ask for one side, then it becomes Q by 6 epsilon naught. Okay, for entire cube means due to the 6 sides Q by epsilon naught. They ask for one side means Q by 6 epsilon naught. Okay, these are the shortcuts we can use for electric charges and fields. And one more thing is there, quadrupole. Quadrupole means it's a combination of 2 dipoles. Okay, see, 2 dipoles means, see, I think one time they given minus 4q, 2q and 2q they given. Okay, if they are arranged, means here 60 degrees, here 60 degrees, here 60 degrees. This we can write minus 4q, we can write minus 2q minus 2q. This is minus 2q and this is 2q and this is one more minus 2q and this is 2q. Okay, here theta is 60 degrees. Why? Because it's an equilateral triangle. Shortcut formula for the quadrupole, shortcut formula P dash is equals to 2p cos theta by 2. 2p cos theta by 2. For this problem, this is the shortcut. Okay, okay guys, understood, Amma? Understood? Hello? Come on everybody, see. These are the shortcuts. Okay, so tomorrow I will explain the problems based on the shortcuts, whatever the problems they given in the previous CET question papers. Thank you very much. Have a nice day. Thank you.